Hello everyone, welcome to our discussion of section 1.3 where we will be talking about application of systems of two equations in two unknowns in business and economics. So in that context we have the break-even scenario to talk about, we have the relationship between supply and demand to talk about, and then we also talk about other contexts. So the break-even scenario there are two approaches that we can take to calculating the break-even scenario. One is if we have the information given to us in terms of revenue and cost, then we can set up the revenue function equal to the cost function and solve for the break-even case, which is usually how many products or services we have to sell in order to break even. In another situation, we might be given the profit function. If we have the profit function given to us, then we set, to solve for the break-even scenario, we set the profit function equal to 0 and then solve for the variable in the equation. So depending on which scenario we have, we can apply these two different approaches. In this example, it says a manufacturer produces a mechanical component at this cost and sells them for this price. If the monthly operational overhead is $9,000, how many mechanical components must be sold to break even? So in this case, as you can see, there is no mention of the profit function. So this case is out of the question. We're using case one where we have the revenue and cost functions to help us solve for the break-even case. Now, before I write down my solution, I want to ask you to pause the video. Please do that. Solve this problem on a piece of scratch paper, and then when you're done, come back to the video and compare your solution with mine. I hope you're not just going to copy down what I write down. All right, so I'm assuming you've done that. Now you're back. And so hopefully our answers agree. So notice that the first step in the problem we've already done, right? In solving a word problem we've already done, which is read the problem once carefully. So now we're familiar with the context of this problem. The second step is assign a variable to the unknown they're asking us to solve. So they're saying how many mechanical components must be sold. So let's assign a variable to that. You can assign any variable. I'm just going to use X and give it and define X as number of mechanical components. And then since they're talking about how much this operation is costing the manufacturer, so we need to set up a total cost function. Now, I remember in Accounting 101, they talk about the total cost function, and let me call it C for cost as a function of variable X, as being the fixed cost plus the variable cost. That's what they say in Accounting 101. So we're going to write that down. And then in this case, what do we have for fixed cost, for example? Well, notice that it says if the monthly operational overhead is $9,000, this is always taken as a fixed cost because it doesn't matter how much you produce of these components, it's still you're paying the rent for that building or the costs for operating the equipment and the building and the utilities, water, electricity, what have you, internet, all those utility connections are part of this monthly overhead, which you would be paying anyway, even if you didn't sell any of these mechanical components. So the $9,000 is our fixed cost. The variable cost is this. It says each of these that manufacturer produces, each of these components cost them $8.75, right? So this is the cost to the manufacturer. per component. Because it's per component, we have to multiply this by X, the number of components that the manufacturer produces. Okay, so obviously then the total cost will be increased if they produce more of these components. The other piece of information we were given is this $19.99, and this is the price for these components as they are sold to the customers. What we charge the customers is always the revenue side of the equation. So that gives us, that amount gives us, let's call that R of X, revenue as a function of X, which is the number of components, is equal to 19.99 times X. Now, we know we have case 1 in this situation, in this problem, so we have to set the revenue and cost functions equal to each other in order to solve for the break-even scenario. And let me, well, I think I have a little more space at the bottom here. So let me write that down. So for break-even, we have to set the revenue equals cost. And let me write the rest of this on a different page. I'll try to keep the rest of this on the screen. So we have the 1999x equals the cost function, which is the 9,000 plus 8.75x. Okay, after this point is just the basic algebra we should do. So solving is always about isolating the variable for which we're solving. So we need to move this x term from right to left to combine it with this. Because it's positive on the right side, when we move it, it becomes negative. So minus 8.75x equals 9,000. Okay. Then if we combine this, and please verify these numbers that I have with your own calculations. And if we divide both sides, so we're solving for x, so we need to isolate it. To do that, we need to get rid of this 11.24. So we're going to divide both sides by 11.24. And that gives us x equals 800.71. Because we're talking about number of components, so let's round this to the nearest whole number. Because this number is oops, I'm almost off the screen there, sorry. So let me scroll this up. So because this number is 7, which is larger than or equal or larger than 5, we can round this 0 up to 1. So x is nearly 801 components. So this is the number of components to produce and sell to break even. Okay. All right. I hope this answer agrees with what you wrote down on your own paper. The next case is the supply and demand. So we just talked about the break-even scenario. Now supply and demand. A couple of definitions are helpful when we solve problems in supply and demand. First of all, market equilibrium is a point at which in the market at which where and when supply equals demand. So these are the keys. Supply equals demand at market equilibrium. Market price is the price at which supply equals demand. Okay, so knowing that, then it says given the following supply and demand equations, and I need find the market price, and let me add the supply and demand equations. S, or supply, equals 40p plus 300, and D for demand equals 1000 minus 3p. Okay? So we know that the market price is the price at which supply equals demand. So let us do that. We're going to set supply equals demand. So that would be this whole equation, 40p plus 300 on the left side. And I hope you paused the video, but it's not too late if you haven't done that already. So then we can solve this. We're solving for p, so let's move all the p terms to one side. This is minus 3p on that side. If I move it, it'll become positive. So 40p plus 3p, and then we have 1000 on the other side. Let's move this constant from left to right because it's positive on the left. When we move it, it becomes negative. So we have 43p equals 700, and we're solving for p, so we need to isolate p. How do we do that? We need to get rid of the 43. So divide both sides by 43, and then we end up with p equals $16.28. So at this price, the amount of products or services that the suppliers are willing into the market, are supplying into the market, is equal to what the customers are willing to purchase. Okay. All right, I hope that agrees with what you have. Another problem would be this one. It's again about supply and demand. So we have here, it says for a certain commodity, the demand equation D is given by this function. And assuming that the supply function is also linear, this is a pretty significant piece of information here. If the supply function is linear, then it's going to follow this kind of pattern. We should be able to represent it as something like this: y equals mx plus b. Of course, this is just the equation of any linear function, but in our case, we will call y s for supply, x, we will call it p for price, and then we will keep m and b the same. Okay, so it says, assuming that the supply function is linear at a price of $1 here, let me change that to $1. So that's a $1. 4 units of the commodity are supplied. Okay, 4 units are supplied. So let's very quickly translate that, because that's part of the solving word problems, right? We read this problem in English form and we translate it into mathematical equations. And if you could please pause the video at this time, solve this problem on your own, and then come back to the video to compare your solution with this. Please do that. Don't leave your paper blank. All right, so I'm assuming you've done that, and now you're back. So because we know the supply function is linear, I'm going to write a supply function that is equivalent to a linear function. So I'm going to say S equals m, which is the slope of a linear function. Instead of x, I'm going to use p for price. And as a matter of fact, let me write it here. P is the price. Plus, I'm going to keep b as the y-intercept of that straight line. So they're asking us to find the supply equation. To find the supply equation, we only need to know what the y-intercept is and what the slope of the function is. So if we know that, and if we figured out these two variables, we can answer the question they're asking. Notice that this is important for us to know how many variables we're solving for, because if we're solving for two variables, then we're going to need a minimum of two equations to answer this question. If you're solving for three variables, then you're going to need three equations to solve for those variables. Okay? Let me, just for this, so that you have this in your notes, I'm going to write it down. So we have two unknowns. M and B. Therefore, we need two equations to solve for M and B. Okay. All right, so let's see how we can figure out one question, one of the equations. So one of the equations comes from this information, right? Assuming that at a price of $1, 4 units of the commodity are supplied. So let's write that down. So we know the supply equation is this. So we have S equals MP plus B, and we are told that S is equal to 4, right? 4 units of the commodity are supplied at a price of $1. So P is $1, right? $1. So let's plug these two into this equation. What are we going to get? So we're going to get 4 on the left side, right? For S, we're going to put 4, and then M is going to be M. We're solving for M and B, right? P is going to be 1, and then plus B. So what are we going to get? We're going to get M plus B equals 4. Right? I just wrote it. This is the same thing as that. I just wrote it so the variables are on the left and the constant value is on the right. Okay? That's how we want the equations to look like when we solve systems. The variables on the left and the constant on the right. So this is one of the equations we need. So we need to look for another one. Now, they also gave us a demand function right here. And then later they say if the market price is $4, remember what the definition of a market price was, right? Just a few minutes ago, it was on the previous slide. Market price is a price at which this demand equals the supply. Okay? And so they say if the market price is that much, find the supply equation. So we need to make use of that information. So let me write that down here. That we know that at the market price of $4, supply equals demand. Right? So then that means the supply, which is equal to all that, MP plus B, should be equal to all of the demand, which is minus 3P plus 20. So let's set these two guys equal to each other. Let's set them up. We have MP plus B, that's supply, equals the demand, which is this, minus 3P plus 20. Right? And this is not always true, guys. The supply is not, I hope you're catching that supply is not always equal to demand. It's equal to demand when at the market price, which is what we have right now. Okay, so let me make sure that I make that clear. This is true at market price of $4. Okay? So we need to substitute for P in this equation with 4. So M times 4 plus B equals minus 3 times 4 plus 20. And then we have, so on the left we have 4M plus B equals minus 12 plus 20. And then, so we end up with, if we clean this up, we get 4M plus B equals positive 8. And this is the second equation that we need. Okay, so we have that equation, we have this equation. Let's set them up equal to each other and solve let's put them together and solve a system. I'm going to write those two equations in a system. So M plus B equals 4. The other equation was 4M plus B equals 8. So I'm sure after this point you realize how to solve the rest of this. You can either use method of elimination or substitution. I'm going to use the method of elimination. So multiply the top equation by negative 1. What do we get? We get minus M minus B equals minus 4. And then 4M plus B equals 8. Notice that multiplying the top equation by minus 1 made the coefficient of B term minus, which is the opposite of plus, so we can add these two equations and get rid of these two, the B terms, and we solve for M. So let's add those two equations. What do we get? 4M minus M, that's 3M, minus B plus B, that adds up to 0. We end up with 3M equals minus 4 plus 8. That's positive 4. And then if we solve for M, we need to isolate M, right? So we need to get rid of this 3. How do we do that? We do that by dividing both sides by 3. So on the left, the 3's cancel out. We get M equals 4 over 3. There we go. So we found the slope of the supply function. Let me write it here. So slope of the supply function. Now we need to find the y-intercept, or B. That B is the y-intercept of the supply function. So we can simply plug this M value into either of these two equations and solve for B, right? We can use whichever. Let's use the easiest one, which I think is the top equation. So using M plus B equals 4, we have four-thirds plus B. So just plugging in here. Plus B equals 4. Let's get rid of the fraction in this equation by multiplying both sides by 3. Right? Then let's distribute the 3 inside the brackets. And the right side is just 12, right? Okay, so what do we have here? We can cancel this 3 with this 3. We have just the 4 from that. And then we have 3b equals 12, right? So let's isolate the b variable, 12 minus 4. And then we end up with 3b equals 8. So we're solving for b, so we need to isolate b, right? How can we isolate b? We need to divide both sides by 3. On the left, the 3's cancel out. B equals 8 over 3. So this is the y-intercept of the supply function. So putting these two together, the y-intercept and the slope that we found earlier, let's do that. If I can keep everything on the screen, let's do that from here and from here. Then we write down the supply function is equal to that slope, 4 over 3 times P for price, plus this y-intercept that we just found, 8 over 3. So there is our supply function. Okay, so I hope this is identical to what you figured out on your own. If not, I hope you see how it works. And if you have any questions, please stop by my office hours or just mention it in class. All right, so that's another problem. Let's go over. So we went over examples on break-even scenario. We did a couple on supply and demand, and I promised you that we will do examples on other contexts, right? So here is an example on other contexts of applying systems of equations to solving word problems. Okay? So before you see my solution, I trust you that you will solve this problem on your own and have your solution ready before you come back to the video to see what I have done. Okay? I trust that you'll do that. Just read the problem carefully, make sure that you know what the context is, and then introduce a variable for the unknown, right? We have no choice but to introduce the variable for the unknown and then set up your equations. All right, so I trust that you've done that. You're now back. You have your solution ready. So let me then catch up with you. So here, the context we're familiar with, it's a ferry that is going from downtown of 2 islands. And apparently there are 2 types of tickets being sold. One kind is for adults. The other one is for children, differently priced. And we have a statement that says 8 times as many adults make the trip on the ferry than children. So let's make sure that we understand this, right? I'll come back to this. But if we read this, I just want us to get a feel for what is the unknown that they're asking us to find. There it is. It says about how many adults made the trip on the ferry that weekend. As soon as you know what's the unknown that you're looking for, give it a variable. So we're going to say A represents the number of adults or adult tickets purchasing tickets. Okay, so that's A. And the other kind is children, right? So let me use C for children, number of children tickets. Okay. Now that we have the variables, we can set up equations and solve this, right? But that's the first step. So this statement is crucial here. 8 times as many adults make the trip on the ferry than children. By the way, since we introduced 2 variables, we're going to need 2 equations to solve this problem. So as we read back here, we're looking for information that helps us construct 2 equations. That's what we're planning to do. So one equation can come from that. 8 times as many adults make the trip on the ferry than children. Let's make sure we understand that. So I'm going to set up a little table here. I'm going to put A for adults on this side and C for children on this side. So according to this statement then, more adults were purchasing tickets than children, right? In fact, 8 times more adults. So that means if one child purchased a ticket, if there was one child on the ferry, then 8 adults were on the ferry. If there were 2 children present on the ferry, then there were 16 adults. If there were 3 children present, then 24 adults were present. So if we continue this, there's definitely a pattern emerging, right? So let's use this table, let's use these 3 specific examples to set up an equation based on that. So if you haven't done this already, pause the video, take about 10-15 seconds, write an equation based on that. Go ahead, do that, and then come back to the video. So I'm assuming you've done that, and then, so we can then say that A, given this information, is 8 times C, right? We can generalize this into this equation. And let me box this and say this is the one of the 2 equations we need. One equation we need. Okay. Where is the second equation coming from? Well, one thing is that, and I forgot to mention this, once we introduce variables, we need to attach information to these variables. And to do that, this is, if this A represents the number of adults purchasing tickets, we are told that each adult ticket costs $50.50. So that information gets attached to this variable A. So $50.50, and the children's tickets are selling for $26 a piece. So using this information, price of each type of ticket, and the total revenue that was collected on that weekend, we can set up a second equation, right? We can set up and say that $50.50 times A plus 26 times C is equal to 438,200. So this is the second equation we need. Right? Like that. Okay, so once we have 2 equations, we can set up a system and solve it, and we know how to do that. In this particular case, see that they're saying how many adults, right? That's the question. They don't care how many children bought the tickets, how many adults purchased the tickets. So in this equation, if we're looking for A, adults, then we need to get rid of this C, right? How do we get rid of it? Well, this first equation can help us do that. Let's solve this equation for C, this little one. So we're going to solve that, and we're going to say that C, or the number of children who bought tickets on that weekend, is equal to A divided by 8. Okay? Now, in this longer equation, we can replace C with this, A over 8. That way we end up with a single equation, single variable, and we can easily solve for the variable we want. So let's do that. So we have $50.50 times A plus 26 times C. Instead of C, I'm going to put A over 8, right? That quantity should be equal to 438,200. So to get rid of this fraction, so now we're just solving for A. To get rid of this fraction, let's multiply both sides by 8. So 8 times all of that equals 8 times the right side. Right? So let's distribute the 8. So 8 times 50.50A plus 8 times 26A over 8 equals 8 times all of that, 438,200 gave me this value. Please double check these numbers. 3,505,600. So let's clean this up. We 8 times 50.50. I got 404A. And here the 8 and this 8 cancel each other out. We end up with 26A equals all of that. Okay, so we have, these two added together, we get 430A. As you can see, I'm running out of space. I'm near the bottom of the page. Equals all of that. So we're solving for A, so we need to isolate A. To do that, divide both sides by 430, and we will end up with A equals this divided by 430, which would be 8,152.558. But let's round this to number of adults. So this is 5 or larger, so we're going to round this up to 3. So A is equal to 8,153 adults took the ferry that weekend. Okay. So I hope this agrees with what you came up with on your own. Let's do another example in these other contexts. So this one says the train ticket price from Paris to London is around this much for those who purchased them 2 weeks before a trip. But look at that. They're much less expensive, right? $70.91 for those who purchased the ticket a month or more in advance. So if you're a tourist, right, if you're just getting there to spend a week or 2 or 3 there and use that, so you're paying this. You're paying the higher price. But for the locals, because they know in advance what they're going to do, they're going to pay a much less expensive price. So it's a good deal for the locals, actually. So then there were 25 times as many tickets sold a month or more in advance of Bastille Day holiday on July 14th than the tickets sold 2 weeks in advance. Okay? So the total revenue from those who bought the train tickets for Bastille Day was over $1 million. Right? About how many tickets were purchased, and that's part A, a month or more in advance. So let us assign, because they're asking for tickets purchased a month or in advance as the unknown. So let's give a variable to this and a variable to the other one, those who purchased tickets 2 weeks in advance, and they paid the higher price. So let's give a variable to those who purchased the tickets 2 weeks before a trip, and another variable to those who purchased them a month or more in advance, right? Let's do that. You can pick your variables to be anything. I'm going to pick them to be X and Y in this case. So X is number of purchased let's make this one 2 weeks in advance. So as soon as we introduce a variable, let's attach information to it, because that's part of organizing this big paragraph, right? So let's organize this big paragraph into an equation or some quantitative data. So for X, they're paying a higher price, right? So they're paying $156.91. Then let's make the other one Y, the other variable Y. So this would be the number of tickets purchased a month or more in advance. Of course, these guys are gonna get a break, so they're paying $70.91, right? So, and then we have a statement here. It says, so notice that we introduced two variables. So we're going to need two equations to answer this question. One of the equations can come from this statement. 25 times as many tickets sold a month or more in advance of Bastille Day holiday on July 14th than the tickets sold 2 weeks in advance. Okay, so let's set up a table like we did for the previous one. And I'm hoping you've already solved this problem. So you're just confirming what you've done with what I'm doing. And I'm going to put X and Y here. Remember that X are those who are paying, who are purchasing their tickets 2 weeks in advance. And we know that those who bought their tickets earlier, there are 25 times more of those people than the ones who bought them a couple of weeks in advance, right? So if one person bought the ticket a couple of weeks in advance, then 25 had already purchased it a month or so in advance. If two people purchased the tickets 2 weeks in advance, then 50 people must have purchased the tickets a month or so in advance. If 3 people purchased the tickets 2 weeks in advance, then 75 people must have purchased the tickets a month or more in advance. So you can see a pattern is emerging here, right? So let's use this information, these 3 individual examples, to write down a general formula or equation for this situation. Let's do that. So we can write down that Y, right, based on this. If you haven't done it, pause the video, because it's really important that you guys do this before you see my solution. Okay, so I'm assuming you've done that and you're back. So Y would be equal to 25 times X, right? That's one of the equations we need. All right. So now we're looking for a second equation because we have 2 variables. Where is that coming from? Well, remember these 2 pieces of information we attached to each of the variables? The price of each type of ticket, and how much was the total revenue? 1,280,000, right? So we can use this information to write a second equation. We know that 156.91 times X plus $70.91 times Y is equal to that total amount. Let me scroll down. 1,280,000. Okay, so this is the second equation we needed, right? So let me just write second equation. All right, so now that you know where this is going, right? Because you have 2 equations, 2 unknowns, you easily can set up a system and solve it. But before that, maybe I can write that on the previous page. Before that, since we're looking for part A, we're looking for how many tickets were purchased a month or so in advance. So we're looking for Y, right? If we're looking for Y, this one, then let's solve this smaller equation for X. So X would be, based on that, would be equal to Y over 25. This is very helpful because in this longer equation, we're solving for Y, and we can deal with X now by substituting for it with this. Y equals Y over 25. Okay, so let me do that here. So just starting with that equation, we have 156.91 times, instead of X, I'm going to plug in this quantity, Y over 25, plus this 70.91 Y equals 1,280,000. Okay, great. So we don't need that page anymore. We can work with this. So that little equation helped us replace X, right? Now we have this instead. One equation, one unknown, just the Y. All right, so let's get rid of this 25 by multiplying both sides of the equation by 25. That, and then equals 25 times the right side. Right? So whatever we do to this side, we got to do to the other side. On the left, let's distribute the 25 to each term. And then multiply this 25 by all of that. I got 32 million. Please verify my numbers if you haven't done it already. And then on the left side, so we have this 25 and this 25 cancel each other out, and we get 156.91 times Y plus 25 times that. I got 1,772.75 Y equals 32 million. Okay? All right. So let's combine these two Y terms. What are we going to get? We're going to get 1,929.66 Y equals 32 million. We're solving for Y, so we need to isolate Y, right? How do we do that? We divide both sides by this number to get this Y by itself. All right, so Y is equal to 16,583.23228. They said to round this to the nearest whole number. Notice that this first decimal value is less than 5, so we're going to keep this 3 as it is. We're not going to round it up. So Y equals 16,583 people purchased the tickets a month or so, a month or more in advance. So let me make that clear here. This is the number of people. Oops, sorry, I'm going off the screen there. So the number of in advance. All right. So then part B of the same problem says about how many tickets were purchased 2 weeks in advance of Bastille Day. Well, we've already have the equations we need for this problem, right? They can ask us anything, we'll be able to answer it. So for this case, we said that we had that little equation, y equals 25x, right? That's one of the little equations we had. So this time, we've already solved for y. So this time, they're asking us for x. So we can substitute here with y value that we already know, which is 16,583. And then solve for x. So if we do that, we're isolating x, divide both sides by 25 to isolate x, and then what do we get? We get almost 663 tickets were purchased 2 weeks in advance of Bastille Day. Okay. So I'm sure you see that the systems of two equations, two unknowns, we can apply them to many variety of useful situations here. And if you have any questions, just stop by my office. So good of you to continue with this video until the end. I wish you a nice day and see you again next time.